This is an example of a quadratic equation, and you're given a formula in the exam you can use to solve these sort of equations. Now the formula you're given looks like this. X equals minus b plus or minus the square root of b squared minus 4ac all divided by 2 lots of a. Now this formula finds the solutions of x which make this equation equal to 0, and a, b and c correspond to the coefficients of each of the terms. So a is the number of x squareds, which is 1, b is the number of x's, which is 5, and c is the additional constant, which in this case is 1. Now what we now do is we put these values into the expression, like so. X will equal minus b, whatever b is, change its sign, so minus 5. Plus or minus, we come to that part later on, the square root of, we have a 5 squared, minus 4 lots of a, c, all divided by 2 lots of a. Now, our next job is to gradually make this simpler. Now then, we know that 5 squared equals 25. Take away 4 times 1 times 1, which is 4, all over 2 times 1 equals 2. Next step, 25 take away 4, 21, all divided by 2. Now then, the plus and minus provide us with two solutions of x. So x is either equal to minus 5 plus the square root of 21, all divided by 2, or x is equal to minus 5 take away the square root of 21, all divided by 2. Now we cannot find without a calculator what the square root of 21 is, and without a calculator we can leave our answers as 2/3. However, with a calculator we could input this expression, press enter and deduce 2 values for the answer. However, we will leave our answer in this form as a third. We'll now run through a second example where the coefficients are not quite as easy, but the solution follows the same steps. Our expression will look like this. This is another example of a quadratic. But in this case, a equals 5, b is minus 3, and c equals minus 2. So, if we now try and put these values into the expression, let's see what happens. X equals minus b. Well, b is negative, so minus b makes it positive. Always plus or minus. B squared minus 4ac all divided by 2 lots of a. Now then, minus 3 squared goes to plus 9. Now 4 times 5 is 20. 20 times minus 2 is minus 40, but another number there, another negative, goes to plus 40. 4 times 5 is 20, times minus 2, minus 40, another negative, cancel out, plus 40. All over 10, which equals 3, plus or minus the square root of 49, all divided by 10. Now, unlike the previous example, where we could not go any further, we can find what the square root of 49 actually is. So x equals 3 plus or minus 7, because the square root of 49 equals 7, all over 10. This means we can now deduce the two solutions. X is either 3 plus 7 over 10, 3 plus 7 is 10, 10 over 10, which equals 1. Or x equals 3, take away 7, all over 10. 3 take 7 is minus 4, all over 10, which equals minus 0.4. And these are the two solutions to the equation there. I will just mention one thing. This particular equation could also have been solved by a method called factorizing, and another video of ours discusses that aspect of solving these sorts of equations. But this focus is on the formula. You're given the formula in the exam. It is your job to revise and learn the steps to solve the given equation using this formula here. There is a particular type of equation called a quadratic equation, which begins to access some of the grade A work. Now I'm going to just talk through what we'll call the basic quadratic equations and give an indication of how it can be extended. So, x squared plus 5x plus 6 equals 0. Now these are solved as long as one has equal to 0 on the right hand side. Now sometimes these expressions can be factorized, and I suggest you might want to look at the video on factorizing, which I've also done. But basically we need two numbers which times to make plus 6 and add to make 5. And it is fairly easy to see that those numbers are 3 and 2. 3 times 2 is 6, 3 plus 2 is 5. And it's been converted into a pair of double brackets. And the reason this trick works is because if one can factorize, we have two things times together to make 0, so either this equals 0 or that equals 0. One of these two things must equal 0, and that can only happen if either x equals minus 3, because minus 3 plus 3 is 0, or x equals minus 2. And these are called the solutions, there are two of them, to that particular quadratic equation. I will now talk through a few more examples. So remember, we're looking for numbers which times to make minus 15, but combine somehow to make plus 2. Now there are not many factors of 15. However, if I put down 5 and minus 3, 5 times minus 3 is minus 15, 5 take away 3 is 2. I have factorized the expression. Either this equals 0 or that equals 0, so either x is minus 5 or x is plus 3. And they are the two solutions of the second quadratic equation. Now it's not always that easy to factorise. This one is a special case called the difference of two squares, where there are no x terms. However, it's actually quite quick to factorise. This is a square number. 7 times minus 7 is minus 49, and there are no x terms because 7 take away 7 is 0. The x terms cancel out. And to make this equal to 0, x must be minus 7, but to make that equal to 0, x could equal plus 7. And they are the two possible solutions to that equation. And in hindsight, it's very obvious because, of course, 7 squared is 49. Take away 49 equals 0. Or minus 7 squared is also 49. Take away 49 equals 0. And the final one in this particular series is this one here. When we have a plus 9 here, and a minus term here. Now then, this is actually a square number, 3 times 3. And also 3 plus 3 is 6, but we have a minus 6 here. Now then, if I put minus 3 and minus 3 in those brackets, minus 3 take away 3 is minus 6, minus 3 times minus 3 is plus 9. So it's factorised. And in this case, the two solutions are the same. Plus 3 and plus 3. They can be called repeated roots, where we happen to have the same solution occurring twice. So in fact there's only one solution to that equation. X equals plus 3. Now we'll just point out a special case, well, or more general case, this one here, where it does not factorise. And it is this point where I will mention a formula which one would need to learn to access the higher grade work at GCSE. And the next video will develop the ideas on this further. This video looks at two examples of quadratic simultaneous equations, and it shows how you can find values of x and y algebraically which satisfies both equations. So in example 1 we are given two equations, and the question is, where are these two equations equal to each other? In other words, where are the y's equal? But if the y's are equal, then therefore these two expressions here must also be equal. So the question is asking, where does x squared plus 7x minus 2 equal 2x minus 8? Now to solve this sort of equation, you need to get all your terms to one side and have equal to 0. Now the x squared term's on the left, so I want to get rid of the 2x by taking away 2x. And I want to get rid of the minus 8 by adding 8. But what I do to the right hand side, I must do to the left hand side. So if I take away 2x, I get a 5x, and if I add an 8, this becomes plus 6, and the right hand side is left as equaling 0. So this becomes quite a simple equation to solve, because it factorises. 2 times 3 is 6, and 2 plus 3 is 5. So we're left with x plus 2 and x plus 3 equals 0. So these two things times to make 0. So either x is equal to minus 2, because minus 2 plus 2 is 0, or x must equal minus 3, because minus 3 plus 3 is 0. Now we're almost finished, but there's a y value as well, and we know y equals 2x minus 8. So if x is minus 2, y must equal 2 lots of minus 2, minus 8. Well, 2 times minus 2 is minus 4. Take 8, minus 12. Or y is 2 times minus 3, minus 8, which is minus 6, take 8, which is minus 14. And there are answers. Actually, 2 sets of coordinates. The first coordinate is minus 2, minus 12. The other coordinate is minus 3, minus 14. So these values are the solutions to these two equations, and it's where the actual curves and lines intersect. Now in the second example, it's similar, but whereas these were both y equals, this one's y equals, but this one here is not. However, there's a little trick we do. Now this y here, where they intersect, where they're the same, must equal this y here. So, if we look at the first equation, we have an x squared plus a y squared. But we know that y equals x plus 4. So I can replace this y by an x plus 4. So we get an x plus 4, where the y was, but it's squared. And this must equal 8. We now expand this. Now don't forget that x plus 4 all squared means x plus 4 bracket x plus 4, and that equals 8. Now to expand this, you use your normal expansion of brackets. It gives us an x squared, 4x and 4x is 8x, and 4 times 4 is 16. We have an equals 8, and we have an x squared. We then simplify. X squared plus x squared is 2x squared, plus an 8x, plus a 16 equals 8. We now want it to equal 0, so we must take away 8. So that will cancel off. However, if we take away 8 there, we must do so there as well. So we get 2x squared plus 8x plus 8 equals 0. The next trick is to look for a common factor. I can divide by 2. So I'm left with x squared plus 4x plus 4 equals 0. This now factorizes. 2 times 2 is 4, 2 plus 2 is 4. So we get x plus 2 equals 0. And so the solution, and the one solution, is x must equal minus 2. Because minus 2 plus 2 is 0, and the same in that bracket there. Almost done. Y is equal to x plus 4, which is minus 2, plus 4, which equals 2. And the coordinate we're left with is minus 2, 2. Now there's one bit of language which you'll meet certainly in AS Maths if you choose to do so, which is when there's only one solution, it's called a tangent. This video looks at a fail-safe method for solving equations involving algebraic fractions. Now first of all, we place brackets around anything either above or below which contains more than one term. So an x and a 2 in brackets, an x and a minus 4 in brackets. We also write the integer, if it occurs within the question, as 2 over 1. Now, the next step is to force each of these three terms to share a common denominator. Now, we take the x plus 2 and we basically force it into the other parts of the equation. But what you do below a fraction, you must also do above. So I must also add an x plus 2 here and an x plus 2 here. So that's the x plus 2 dealt with. I then take the x minus 4 and do the same thing. So I force it in down here, and therefore on top as well. And I also force it into the one over here. I therefore do it the top as well. Now, these three parts of the equation therefore now share a common denominator, albeit with it swapped around for the middle one, but it's there in all three. So I can now just literally cancel off the denominators because it's an equation. And so I'm left with the following: 5x minus 4 plus 3x, x plus 2 equals 2x plus 2, x minus 4. Now, to solve this requires us to expand the separate parts first of all. So 5x take away 20, which I'll put in a bracket, plus the next part, 3x squared plus a 6x. Now then, be careful with this part here. There's a 2. We then expand this using either a smiley face or FOIL or grid method. X times x, x squared. 2x take away 4x is minus 2x. And 2 times minus 4 is minus 8. So we've expanded the brackets, apart from the very last 2 there. And we then begin to make it simpler. So look at the left-hand side. There's a 3x squared there. There's a 5x plus a 6x, which is 11x, and there's a minus 20. And this must equal this part here doubled, so in other words, 2x squared minus 4x minus 16. Now then, the trick now is to get all the terms to one side. And you look for the highest x squared term, which is this one here. So let's get all the things to the left-hand side. So I don't want that there, so I must take away 2x squared. I don't want that there, so I must add 4x. And I don't want that there, so I must add 16. That leaves that side equal to 0, but I must do the same to the other side. So 3x squared take away 2x squared is just x squared. 11x plus 4x is 15x. And minus 20 plus 16 is minus 4. So we have an equation equal to 0. So to solve this, there are various methods. Step 1, it might factorise. But this doesn't factorise, so the only option, really, is to use the formula, the quadratic formula, which tells us the solutions to a quadratic equation, which is as follows: x equals minus b plus or minus b squared minus 4ac all over 2a. Now, the a, b and c in this are the coefficients in the equation. So a is the number of x squareds, so a equals 1. b equals plus 15, and c equals minus 4. Right then, so x equals minus b minus 15 plus or minus the square root of 15 squared minus 4 lots of a lots of c. C is negative, all over 2 lots of a. So x equals minus 15 plus or minus the square root of 15 squared is 225. 4 times 4 is 16. 2 negatives goes positive. All divided by 2. Now we're almost there. Minus 15 plus or minus the square root of 225 plus 16, 241, all over 2. Now, these are two solutions left in the form of a surd, either minus 15 plus or minus 15 minus this square root all over 2. And we'll leave it as a surd, like so. This video talks through how the quadratic equation question can often be phrased in the AQA examination. And it's often given in the form of an operator, in which it gives you an A and a B and defines this triangle thing here to mean this equation. This has been made up completely. It's nothing special, but we're then told to solve an equation, x operator 3 equals 0. Now the trick here is as follows. Let's rewrite this over here. And underneath, I'm going to write down the question, x triangle 3. Now the trick here is to rewrite this with a replaced by x and b replaced by 3. So a is x, b is 3. So a squared becomes x squared, 3a becomes 3x, b squared becomes 3 squared, which is 9, and then take away 7, which becomes x squared plus 3x plus 2. So x operator 3 equals x squared plus 3x plus 2. So to solve this equation is the same as x squared plus 3x plus 2 equals 0. Now this can factorise. 1 times 2 is 2, 1 plus 2 is 3. So x plus 1, x plus 2 must equal 0. To make this bracket equal to 0, x must equal minus 1. Or, for this bracket, x must equal minus 2. And there are solutions to this equation there. This video suggests a way to do the harder factorising when the number before the x squared is not equal to 1. Now this method, you look at the number before the x squared and look for its factor pairs. The factor pair of 3 is 3 times 1. You then ignore, for the moment, the 7x and look for the factor pairs of 2, which is just 1 times 2. Now, to then factorise it, we use the following method. We put these two numbers here in a column, and then we put these two numbers next to it also in a column. And we try to pair the numbers off to make 7 in the following way. If I do 3 times 1 and 1 times 2, 3 plus 2 is 5, not 7. But if I do 3 times 2 and 1 times 1, 3 times 2 is 6, 1 times 1 is 1, and 6 plus 1 is 7. So this pairing off gives us a 7 as required. So to make the brackets, to actually factorise it, we put our two brackets down. Now, the first column tells us the x. So 3x for the first bracket and 1x for the second bracket. And this tells us that the 3 gets timesed by a 2. So the trick here is the 3x gets times by a 2. I must put the 2 in the other bracket. Because when you times brackets, you do 3x times by 2 like so. And the 1x gets times by a 1. So I must put the 1 also in the other bracket. So to show how this works, 3x times x is 3x squared. 1 times 2 is 2. 3x times 2 is 6x. 1 times x is x. 6x plus x is 7x. So we'll talk for this again for another example to show how it still works. So again, it's 3x squared. The only factor pairs are 3 and 1. But for the 6, it's either 1 times 6 or 2 times 3. So we have two options to consider, one of which will work. So I put the 3 and the 1 down a column. I'll try and do the 1 and the 6 first. 1 and 6. Can I somehow make 11x? Well, 3 times 1 is 3, 1 times 6 is 6, 3 plus 6 is 9, not 11. 3 times 6 is 18, 1 times 1 is 1, 18 plus 1 is 19. So that doesn't work. So I can ignore that. But I can then try and do 2 and 3 instead. 3 times 2 is 6, 1 times 3 is 3, 6 plus 3 is 9, no. But 3 times 3 is 9, 1 times 2 is 2, 9 plus 2 is 11. So we've found again the correct configuration. So the trick here is to put it into brackets. So 3x and x, 3x and x. The 3x gets times by a 3, so I must put the 3 in the other bracket. The x gets times by 2, so I must put the 2 into the other bracket. And again, 3x squared, a 6, a 2x and a 9x gives the 11x. Now this method can be adapted to when the third term is negative, but we do the same technique with a subtle change at the end. So again, this one still is 3x squared, which is 3 times 1. Look at the 5, ignore the negative for the moment, that's 5 times 1. So 3 and 1, 5 and 1. And we'll somehow pair these off to make a 14, but one of them must be negative. Now watch this. If I do 3 times 5 and 1 times 1, I get a 15 and a 1, but 15 take away 1 is 14. So if I put a negative here, I get 15, take away 1 is 14, and 5 times negative 1 is negative 5. So, my brackets, 3x and x. The 3 gets times by a 5, so I put the 5 in the other bracket. But the x gets times by a negative 1, so I put the negative 1 in the other bracket. And to show how this works, we get a 3x squared, a minus 5, a 15x and a minus x gives a 14x. So when it's a negative for the third term, one of those numbers must be negative. So for the fourth one, we've now got a 2 here rather than a 3. So that's 2 times 1. I've got a 3, which is 3 times 1. So I'll put the 2 and the 1 down here, and the 3 and the 1 down like so. I must get a 5x, but a negative 5. Now watch this. If I look at this and do 2 times 3 is 6, and 1 times 1 is 1, 1 take away 6 is negative 5. So if I make that a negative, I get 1 take away 6 is negative 5, and 1 times minus 3 is also minus 3. So if I produce the two brackets, the factorizing, 2x and x, the 2 goes with a negative 3, so the 2x goes with a negative 3, the x goes with a 1, the x goes with a 1, and again, 2x squared, a minus 3, but a 1x, take away a 6x, is a minus 5x. So that has now been factorized. I'll just finish by talking through one application of this. Suppose you were asked to solve 2x squared minus 5x take away 3 equals 0. Because we have factorised this into brackets, this is the same as 2x plus 1, x minus 3 equals 0. Now if two things times to make 0, these factors must be 0. So either 2x plus 1 equals 0. This tells us that if I take away 1 from both sides, 2x equals minus 1. So x equals minus 1 divided by 2. That's the first answer. The second one is where x minus 3 equals 0. If I add 3 to both sides, x will equal 3. And they are the two solutions to that quadratic equation. Now this method will work for some people, not for everyone. And another video I'll produce later on will show a longer way, but another way to factorise expressions like this one. In this question we're asked to solve two simultaneous equations, both of the form y equals. Now the method here is to substitute, because I know that y equals x plus 4. So this y here can be replaced by x plus 4. So I get x plus 4 equals 2x squared plus 3x minus 1. Now to solve this equation I need 0 equals. So if I take away x and take away 4, I get 0 equals 2x squared. I've taken away x, so I get a 2x. And I've taken away 4, so I get a minus 5. So I need to now try and solve this equation. Now to solve this, I can use the quadratic formula. Minus b plus or minus the square root of b squared minus 4ac all over 2a, where a in this case is 2, b is also 2, and c is minus 5. So I put these values into the formula. So x will equal minus b, well b is 2, so minus 2, plus or minus the square root of b squared is 4, minus 4 times a times c, which is minus 5, all over 2 times a, which is 4. Right then, I'll now work out the square root part. Now we're taking away 4 times 2 times minus 5. 4 times 2 is 8, times 5 is 40. There are two minus signs there, so it's 4 plus 40, which is 44, all over 4. So I can now work out two values for x using my calculator. So fraction button, minus 2, I'll do the plus 1 first, plus root of 44, and then divide by 4. So minus 2 plus root 44 over 4 gives me the answer of 1.16 to 2 dp, or I can change it to a minus root 44, and I get the answer of minus 2.16 to 2 dp. And then to find y, I will then just add 4 to these values. So 1.16 plus 4 is 5.16, or minus 2.16 plus 4 gives me the answer of 1.84. Again, to 2 dp. So I have found two pairs of answers for x and y, both to 2 dp. To solve this quadratic equation, we will use the quadratic formula, which we know is minus b plus or minus b squared minus 4ac all over 2a. Now in our equation, a is the coefficient of x squared, so a is 6, b is the coefficient of x, and c is the constant. So our solutions are x equals, so minus b is minus 2, plus or minus, so b squared, 2 squared is 4, minus 4 times a times c, all over 2 times 6, which is 12. So 4 times 6 is 24, times by 5 is 120. There are two minuses, so 4 plus 120 goes to 124, all divided by 12. So again, there are two negatives, so it becomes 4 plus 120 because the two negatives cancel out. So to find x, we have to work out this here with a plus and a minus. So, fraction minus 2 plus the square root of 124 divided by 12, press enter, press the SD button, and we want it to 1 dp, so the answer is 0.8. So x equals 0.8 is our first solution. For our second solution, we change the plus to a minus, press enter, and this solution is minus 1.1 to 1 dp. So there are our two solutions. This question asks us to solve the following pair of quadratic simultaneous equations. Now then, we know that y equals 2x squared plus 4, but we also know that y equals 10 minus x. So I can replace this y here by 10 minus x. That's called substitution. So 10 minus x equals 2x squared plus 4. Now to solve a quadratic equation, I must get the equation equal to 0. So if I were to add an x and take away a 10 from both sides, then they cancel off and I get 2x squared plus an x. I've taken away 10, so minus 6. So the question is does this factorize? Well, if I were to put a 2x and an x, then the factors of 6 are 3 and 2. So it's 3 times minus 2, maybe, or minus 3 times 2. I'll try that combination first. And if I were to put a plus 2 here and a minus 3 here, then I get my 2x squared, my minus 6, and I get a 4x minus a 3x, which is an x. So, either 2x take 3 equals 0, so 2x equals 3, therefore x equals 3 over 2, which is 1.5, or x equals just a minus 2. So they're my two solutions for x. If you don't want to factorize, then you could use the quadratic formula to solve that equation, where a is 2, b is 1, and c is minus 6. We get the same two solutions. I found x, so I must find the corresponding y values. Now when x is 1.5, y is 10 take 1.5, which is 8.5. When x is minus 2, y is 10 take minus 2, which is 12. And they are the two solutions to the pair of simultaneous equations. This video looks at how we can solve where a reciprocal graph intersects a quadratic graph using simultaneous equations. Now, where these two graphs intersect, the y-coordinates must be equal. So therefore, at the point of intersection, we can say that 1 over x minus 3 must equal x squared minus 4x plus 1. So the two equations must be equal to each other. So therefore, I need to solve where these two equations are equal, i.e. solve this equation. So if I put brackets around the bottom and the top, like so, and then times up by x minus 3, I get 1 is equal to x minus 3 bracket x squared minus 4x plus 1. So if I now expand this right hand side, I get 1 is equal to, so I times by x through, and then times by minus 3, x cubed minus 4x squared plus x, and I times by x, take away 3x squared plus 12x minus 3, and I times by minus 3. If I then simplify, 1 equals x cubed minus 7x squared plus 13x minus 3, then set equal to 0, 0 equals x cubed minus 7x squared plus 13x minus 4. So that is the equation which I need to somehow solve. Now let us suppose that we were told that one of the solutions is that x is equal to plus 4. That is a root of this equation. And we want to find the other two solutions if they exist. Now if we know that x equals 4 is a root, then therefore we know that x minus 4 is a factor. So to find the other factors and hence the roots, I divide this expression by x minus 4. So I want to work out what x cubed minus 7x squared plus 13x minus 4 divided by my factor is. Now for this I use a grid method. So I put my factor of x and minus 4 down the left hand side, and then work through as follows. Okay, I want an x cubed. So therefore x times what is x cubed? Well, x times x squared. And minus 4 times x squared is minus 4x squared. But I want a minus 7x squared, so I need another minus 3x squared up there. These two terms combine to give minus 7x squared. I've already got an x, so I need a minus 3x. Now minus 3x times minus 4 is plus 12x. I need a 13x. I need one more x. And x times what is x? Well, x times 1. And to check this, 1 times minus 4 is indeed minus 4 as required. So therefore, if I divide through by x minus 4, I'm left with the top line, which is x squared minus 3x plus 1. So therefore, this whole thing here factorizes to x minus 4 bracket x squared minus 3x plus 1. That's my known factor, which gives my known root. To find the other two solutions, I must somehow try and solve x cubed minus 3x plus 1 equals 0. And to do that, I would probably use the quadratic equation. So x is equal to minus b, which becomes plus 3, plus or minus the square root of b squared, which is 9, minus 4 times a times c, which is 4, all over 2 times a. So x equals 3, plus or minus the root of 5, all over 2. So I've got one given solution to help us solve the equation, followed by the other two roots down here.